Dear colleagues, I am pleased to present to your attention the result of a study on selection of the optimal option for the transformation of the shelter object into an environmentally safe system using the factor-criterion model of scenario analysis. The study was performed by a team of authors from the Institute of Safety Problem of Nuclear Power Plants, strategic consulting company Pleiades, and the Institute of Mathematical Machine and System of the National Academy of Science of Ukraine. The content of my report is as follows: brief description to research object, description of the subject of the research, new safe confinement and task for their removal, model for cooperative analysis of scenario of the shelter object transformation, result and conclusion. So, the object of our research is a complex shelter object, new safe confinement. The transformation of the objects of study is shown on the slide. After the accident at the fourth block of Chernobyl NPP, the so-called sarcophagus, the shelter object, was constructed. After the critical period of its operation was reached in 2007-2016, a unique structure was created, Ark, over the shelter. In 2016, the Ark was successfully slid over on the shelter, and the new safe confinement system was finally accepted for operation in 2019. After the accident, fourth unit of the Chernobyl nuclear power plant, a huge amount of radioactive and fuel-contained material was generated. No doubt, over the past 37 years, various factors have degraded fuel-contained materials and destroyed structure. An example of the degradation of basic material is shown on the slide: brown ceramics and its degradation, black ceramics and its degradation, so-called elephant food and its degradation. Thus, accumulation of fuel-contained materials continue to be the main source of the hazard on the shelter. Moreover, it increases over time as a result of spontaneous destruction of the surface of powder-like physiums with the formation of high-level dust. This is a radiological hazard not only of a local but also of a global nature, since the new safe confinement is not a celted structure. Therefore, it is extremely important to remove of transverse physiums to a controlled state before the process of their destruction can become large-scale. To ensure nuclear and radiation safety of the facility, it is necessary to remove radioactive material and fuel. Currently, the new safe confinement system is considered in the technological space of interconnected retrieval zones. At the same time, each zone has its own technological scenarios for the radioactive material retrieval using different technology. Zone 1 central hall, Zone 2 subapparatus room, Zone 3 stream distribution corridor, Zone 4 machine room, Zone 5 space behind the perennial walls, 6 rubble under cascade wall, and Zone 7 sole local zone after new safe confinement. Is currently considering 3 strategies for material removal and 10 scenarios for their implementation presented on the slide. Selecting scenarios and organizing them is difficult. The decision-making process is influenced by a large number of both internal and external factors. To build a model for comparative analysis of scenario, 11 indicators were selected to be taken into account when selecting scenarios. They were selected based on the recommendation of the International Atomic Energy Agency, Ukrainian legislation, and experts of the field of radiation safety. At the stage of preparing of the data for building the model, they are grouped: security factor with its own criteria, financial factor, and infrastructure component and its criteria, and introduce the concept of scenario value signification function of the three constituent factors with their own criteria. The process of comparative analysis of scenario can be implemented on the basis of a three-level model. Level 1, determination of factor and their criterion content. Level 2, assessment of factor weight and criteria weight for them. And level 3, determination of the complex value of the scenarios. This will allow them to be ranked by value. It should be noted that to determine the importance of the factors and their criteria, a group expert assessment was used on a 0-9 rating scale. At the first stage, the weight of the factor are determined based on expert opinion, using a similar scheme to hierarchy analysis methods. Result is a vector of factor weights. At the second stage, according to the similar scheme, the weights of the criteria for each group of factor are determined on the basis of pairwise comparison matrix. Results, weight of criteria. And the next stage, a vector of complex indicator is formed, which contain estimate of weight of the criteria and estimate of the weight of the relevant factor. And on its basis, a vector, a complex weight values of scenarios is determined using the geometric mean weighting formula. The results is the ranking of scenarios by value from argmax to argmin. The following slide demonstrates the practical implementation of the model based on a peer review of the factors and criteria, evaluation of the factor weights, assessment of the weighting coefficient of the factor criteria, and comprehensive assessment of scenarios and their ranking. And finally, conclusion. The expert assessment of the factors and their criteria are competent and consistent. The calculated factor weights of the criteria for the scenarios based on the comparison matrix are reliable and significant. The vector of the relative comprehensive assessment of the scenario is the basis for making management decision. According to the Argman's principle, the best scenario is the scenario 1. The worst scenario, according to principle Gmin, is scenario 2. Thus, with proper financing of the work of the physicists retrieval of solid waste, the priority of the baseline scenario 1, retrieval of all solid waste accumulation during the new safe confinement's life cycle. In this case, the new safe confinement infrastructure is used as efficiently as possible, and the cost of creating protective barriers for radioactive materials and other infrastructure costs are reduced. The direction of further research is application multi-criteria optimization technique and multi-factor multi-criteria analysis. But here there are great difficulties with the definition of the criteria of the financial factors. Thank you for attention, and please ask your question in the chat. I am currently in the city of Chernobyl, and our internet connection is very unstable. Thank you very much.